Hi, my name is Reed Albergotti. I am the technology editor with Semafor. Today, you're going to see a conversation with Runway Chief Technology Officer Anastasis Germanidis. Runway, if you don't know what it is an AI model that generates video. And it's sort of I think of it as sort of the original Hollywood AI creation tool. It was used in Everything, Everywhere, All at Once, albeit in a very kind of specific and narrow way, but just to give you a sense of how far they go back. Now the tool has advanced to a degree that, I mean, according to Anastasis, every single major Hollywood studio is using it. You can actually edit video that you shot with an actual camera, add generative things to it, or just use it as an editing tool like a traditional one, with sort of your own customizations. And what I like about the Runway people, and I've talked to the CEO at times in the past, is they really think a lot about how AI is going to affect the future of art and creativity and movies, TVs, TV shows, advertisements. I think they get a little philosophical about it. And I think it's great to sort of talk to these people and get into that philosophy, because oftentimes we hear this sort of actors and creatives versus the AI people, and it's not really that. I think what we're really seeing is more of a melding of those two things, and this being used as just sort of the next creative tool. And I think the big question I have, and I get that maybe you get some sense of it from this interview, is when are average everyday people going to be able to make kind of feature-length Hollywood films, maybe without even any actual actors? Could you actually be a famous Hollywood actor when you don't even ever show your actual face in a movie? I've interviewed Cristobal, before, and I've been following the company. But I thought I'd start with, you just released the new Aleph model. And I thought maybe just starting out, I'd love to get a layout, just a general sense of what are the product offerings today that you're offering, studios, and now I know robotics companies. What's the lineup?
Yeah, so we have our main tool that's being used by most of kind of customers of Runway. It's still kind of the same that it was a few years ago, but obviously a lot has changed in terms of the model capabilities that it offers. Our goal in general is to have models that are powerful enough to be used by kind of customers that are in media, that are customers in games, that are in e-commerce. There's kind of many different audiences that benefit from the same underlying models. And the main capabilities that we currently have in the product are image and video generation and editing capabilities. So with Aleph, we have a model that's able to handle a wide variety of ways of transforming and generating video. And we don't have specific offerings for edit capabilities that are like a specific tool for adding objects or a specific tool for removing objects. We have a single model that can basically understand what you're trying to do and be able to respond to those instructions. And similarly for the image side as well. So the biggest upgrade this year has been our Gen 4 model. That's our flagship kind of foundation model for video generation, and Aleph is built on top of that and offers additional control and capabilities on top of that. And I would say, if we look at what's been the biggest unlock over the past few months, is this idea of consistency. So being able to maintain the characters, environments, the objects that you wanna bring into your story, or if you're making advertising campaign, if you're making assets for a game. It's not that every asset that you generate has a different kind of character or different or the environment has changed significantly. You can maintain that consistency across everything that you do, which is a very critical aspect of I think most creative workflows.
What's the target customer at this point? I know you're expanding into robotics and other things, but I don't want to get into that. But just for this basic, for the core business right now, is it still film studios or production companies doing ads and movies, and how many customers?
We have the majority of like top tier film studios and ad agencies work using Runway. I think that's our biggest and kind of core audience. We have the kind of top startups using Runway. We have for any kind of marketing needs or that they wanna use the tool for. We've seen over the past year a lot of growth inside for e-commerce and gaming companies specifically. Those are two kind of big customer groups that we're seeing a lot of traction on. So it's a very wide ranging audience, but they benefit from the same underlying tools.
You go back to like Everything Everywhere All at Once, which I know used the tool, but for a small part of the film, right? And I think is that small part becoming a bigger part? Like, is there anybody who's actually this has become sort of like their primary, tool of, for editing and that sort of thing?
What has really changed over the past year has been that the outputs of the models are being used for kind of what's called the final frame. They're actually used for the outputs that the audience sees on screen. And that's very different than where we were a few years ago, where we had specific post-production tools that were being used very actively and used in kind of Everything Everywhere All at Once, for example. But a lot of the usage of the generative models was on the pre-production for like storyboarding, for pitching ideas. And what we're seeing this year is actually kind of a lot of that usage is moving to production. And we're seeing film studios using those models directly for kind of the final things that get distributed. And a lot of that has to do with improvements in the model capabilities and the realism, the kind of quality that you can get from those models, and also the level of control as well.
I thought it was interesting with the Aleph announcement is that it's like basically if I understand it correctly, you can take footage that you filmed yourself, and then you're editing that, right? Like you would in in one of these, traditional editing suites, right? So, but you're using generative AI to do that, right? But it's not actually, it's like in some sense, I know part of it is you could add things to it using generative AI, but you could also just edit it, right? You could just say, I want this kind of a cut. So is it purely generative, or are you sort of like, bring us under the hood a little bit? How does that actually work? Is it a mixture of, sort of deterministic and non-deterministic, software?
Yeah, so it's powered by generative models. So there is some non-determinism involved in every kind of output that you create using those models. The difference is that you can add their stuff from scratch, like with a text prompt, and generate something, or you can start from either an existing generated video and like edit it further, or you can start from real footage and create like new angles of the same scene, or remove things in the scene. And so it's akin to with language models, you can have the model write an essay from scratch, or you can take something that you've written and then edit it further. The models should be I think it's very important for those models to have those in context capabilities, where they don't just create things from scratch, but they can also understand what you're already providing as context to the model and further refine it. And a lot of the workflows that we see involve this like multi-turn aspect, where you're continuously kind of refining and like kind of and editing what you're creating, which is what most things that end up in production, you're not going to be able to do one shot. You want this like iterative aspect, and it fits like the creative workflow a lot better.
Are you seeing any consumer use or like prosumer, people playing around with this stuff in any significant level?
Yeah, so we have our usage is kind of across the board. I would say we've been primarily focusing more on people that are using those models for a more professional capability sense. But we have within that group we have kind of independent creators. We have smaller teams. We have and then we have kind of large enterprise customers or film studios and ad agencies. So there's a wide range of folks that are using those models.
I did this story actually about a screenwriter trying to to sort of use ChatGPT to write a screenplay, right? You get into these controversial areas, right? And I think, one thing, one screenwriter told me was that he heard from a Hollywood studio saying, "I can't wait to not hire screenwriters anymore," right? And I'm sure that people are saying stuff like that about actors too. Like, I can't wait to where it's all just computer generated. And I think one of the things that I sort of wonder though is if you don't have to do those things, let's just assume that world exists at some point for hypothetically, you also don't really need the film studio either in that world as much, right? You could see a world where it is it's independent filmmakers who are just creating things from scratch or with a very, very low budget. Do you think that how close are we to that sort of thing happening, do you think?
I think so. A lot of those roles institutions probably will evolve, but I don't think there is necessarily gonna. It's difficult to say they're gonna go away. I think it's more likely that they're gonna evolve over time. So if you take a kind of actor's role, for example, we released a model that's called Act 2 that basically allows translating an actor's performance very precisely into a target character. And that's a way that you can kind of leverage the ability to create really compelling kind of performances that have very precise emotional depth and make sure that those are preserved in what you're creating. I think that a lot of those skill sets are still remaining relevant. They're just transformed in the way that you might not be acting necessarily in kind of real world set as much, but that skill set of just being able, the core of what you're good at, it still translates and still is relevant. So yeah, definitely there's a lot of empowerment of individuals are now able to do a lot of things that traditionally required very expensive and required having access to a crew, and you can do those things by yourself. But it's very often difficult, I think, to make exact predictions of how those roles are going to change. And generally, I think the human creativity and ingenuity can always surprises, and there is new roles that people didn't expect would exist that end up being created.
Are people using it in a sense of like a way to sort of, it's almost like digital makeup or something? You could, or digital costume?
Yeah, you can effectively, upload a video of yourself and then, add, do any of those transformations. So it can definitely work for that purpose.
I mean, I wonder if there's and maybe it's too early to ask this, but are you seeing the rise of actors who are maybe just really good at sort of doing the baseline acting, and then sort of studios or whoever it is can sort of add a runway skin over them and sort of and just sort of use their core acting skills in a way? Is that happening?
That's starting to happen. I think it's kind of analogous to voice actors, for example. There is, and that's one example of there's essentially new creative roles that are being created that for people that are especially good at kind of utilizing those models and it's difficult to predict those roles until before you actually start to use those models.
You could see of course you could change your voice too, right? I mean, you sort of keep the inflection, intonation, but change the sound. I mean, you'd almost see a place where even it doesn't matter if you're male or female or what, as long as you can sort of provide that baseline acting, you could sort of be any character on camera, so to speak, right? That's where we're headed?
We're seeing that you can effectively kind of translate your performance into a human or non-human character, of any style. You have this really amazing flexibility now that wasn't possible before, that required a motion capture kind of equipment or set.
Right. Of course, it's part of what makes acting, or part of what creates the value, an actor's value, is their look, right? Their look and their, and that's what sort of gets them the big bucks to be in like the next film. And I would imagine like the sort of the pool of people who could be great actors increases a lot in this world where you don't have to have a specific look or a specific sounding voice. You can sort of just be a really great actor.
Yeah, I guess maybe one way of putting it is that you have a bit of like unbundling of those skills. So like if you're amazing at like the performance itself, you can just focus on that. If it's more about the identity of the actor, like you now have like models that allow for like this character consistency where you can put the same person in different settings or like have different or essentially kind of bring that actor in like new stories or new worlds very easily. So there is that flexibility that those models enable.
It's a crazy world that we're heading into. I heard it was an interesting interview actually recently. Like Demis Hassabis was on Lex Friedman. I was listening to this interview, and he was talking about Veo 3 and the way that let's say you have a scene where there's water. It's actually his view is like it's actually sort of the model is almost like simulating fluid dynamics. It's a physics engine in a sense, or like an end around like a traditional physics engine that you might use to like predict weather, etc. Is that what you think is going on like under the hood with these models? Are they actually learning to predict physics using neural nets?
So that's a position we've had for quite a long time. I think a few years ago we published this essay that we see video generation models as general world models. The more we put compute and data and scale those models, the more capable they become at simulating reality. And we see, for example, in kind of different scenarios in like solid mechanics and fluid dynamics, that we have benchmarks for all those things. And like the more we scale those models, they become better, very predictably at simulating reality. They're not perfect, obviously. There's a lot of failure cases. There is a lot of improvement, especially in like simulating human behavior and like complex motions. But at the same time, like what we've seen in language, for example, is like there were the same sort of questions of like whether language models will become reliable coders or they're going to be able to solve the most difficult kind of math problems. And they've been able to improve very rapidly and faster than people expected. So the same will happen on physics challenges as well.
How do you know though if you say your next model has this great benchmark, say in simulating fluid dynamics? How do you know that what it's not really doing is just like getting better at prediction of that next token or whatever you want to call it with video? And really just mimicking what it has seen in the world. Like, how is there a way to test that?
I guess one answer to that would be that prediction is the basis for understanding. If you can predict what happens next, then that's a very strong proof point that like those models have strong representations that allow them to understand those things. I think what you're getting at is this idea of like can those models generalize? Can those models learn in kind of unseen settings that they're able to kind of perform really well in unseen settings, and that's a lot of what those benchmarks are measuring is this ability to in things that the model hasn't seen or hasn't been trained on, is it able to actually make good predictions? And the answer is increasingly like that it's able to create very realistic simulations of those settings.
What's the latest, like if you can think of the tests that you've done on those benchmarks, is there one that sort of blew you away in what it was able to do recently?
I think in particular the ability of those models to do fluid simulation is pretty amazing, and it's one of those things that I think one of the counterintuitive things about the capabilities of those models is they've gotten better on things that they struggle on things that are more that might be more easy to simulate on like with traditional methods, but they're very good at things that can be very expensive to simulate with traditional methods. So there is that counterintuitive way in which like those models get better at not the things that necessarily you would expect. But yeah, the ability of those models to simulate, kind of to do fluid simulation, is particularly amazing.
This is one of the most difficult things to do, and it takes a huge amount of computational power with physics engines, right? With weather prediction. But I would love it if you could like tell me what the actual test is. Like do you say create a video of, water doing this and it does it, or is that how those tests work?
Yeah, so those benchmarks, essentially you need to have a ground truth, right? You need to compare against some some real video or some real example. You essentially have different settings where you have like, let's say, a ball hanging from the ceiling, and then you perform like an image to video generation, and you watch like what the trajectory of that object ends up being in the generated video. You compare that with the trajectory of the real world video that you took, and then that difference essentially tells you how realistic the generated video is. So you want to be as precise as possible in like determining whether the trajectories that are predicted by those models end up being kind of accurate and correspond to kind of real trajectories.
Have you ever taken like something like that would be more complex, like for instance, like when that boat hit the bridge in Maryland, right? And there was like a video of it, and you say like, what would happen if a boat hit this bridge, and then like look at the difference? Like, is that something you would do, or?
Yeah, I imagine. Not that particular example yet, but I think as these models get better, like you can have more complex scenarios like that, where you're able to actually predict what happens next and compare it with the ground truth.
What's the barrier to that capability today? Is it just the models you need to just scale more data? Is it more memory?
A lot of it is compute and data, and just increasing the amounts of those things. One thing I like to say in general is we still haven't trained models on the vast kind of majority of the observations of the world, like of the outcomes of scientific experiments, of the sensor data we have available to us. And so like there is a lot of kind of conversation about hitting a data wall, but it's important to remember that that's in a very narrow domain of text and of kind of human generated data. But we haven't yet trained at the large enough scale on kind of the vast majority of observations that we collect from sensors, from experiments on a daily basis. And the moment we do that, we're going to build more and more powerful kind of simulators of the world. It's much more difficult to kind of collect that data and figure out on the research side how to build really great models around that data. But for me, it's the next frontier. Is really, in order to solve the challenges that really matter in the real world, you need to build those simulators and use them to solve those problems.
Have you done any experiments with sensor data in the pre-training?
It's we haven't gotten there yet. I think our focus has been still on the visual domain, but as those models scale further and as we improve capabilities, we're going to be doing kind of broadening kind of the domains at which we train on.
How do you think that will look? Do you think sensor data is combined with the video, video data and text, and it's all part of the same model? Or do you think there will be like sensor models that are just sensor data?
A lot of those kind of more single modality, let's say, model like already exist. So there's a lot of efforts in scientific ML and other areas to essentially train a model on weather and climate data. I think what we're seeing and what we saw, and I think that was the biggest insights from the past 2 years of deep learning, is this notion of generality. You started from language models that could only do translation or coding or math, and then you ended up with a language model that can do all of those things. You started from visual models that could only generate faces or animals or paintings, and now you have visual generators of essentially everything. So I see no reason why the same level of generality is not going to be achieved as we incorporate new modalities, and that's for me like where things will head. Like you're gonna have unified approaches, unified models that incorporate more and more of that data that's available in the world, and there's a lot of benefit from that because those modalities kind of end up informing each other. And like if you have a single model that can solve all those different tasks, it becomes, if it's good at one task, it can transfer some of the capabilities in other tasks as well.
How are you going to get that data? Will you have to sort of create a lot of that yourself, or are there sources of some of these new modalities out there?
Yeah, we do a lot of work on the data partnership side to essentially work with a lot of companies that specialize in different data sources, and I don't expect us to be, to specialize in all of those domains. It's more like figuring out like what are the right companies to partner with and collaborate with for each of those.
You're talking about companies like Scale?
Yeah, there is annotation companies, that's one, but I'm talking more about partnerships in areas like robotics, in areas like self-driving, to collect data that's specific to the problems that they care about, and that's different from the kinds of data that's relevant for, let's say, creative purposes.
And the fact that that these are sort of becoming, in a way, these physics engines, is that really what's driving, like, what makes this kind of stuff relevant for the robotics companies and self-driving companies?
Yeah, so in my mind, simulation is the big bottleneck that's going to be required to solve in order to solve challenges that are in robotics and self-driving, in any real world problems that one might care about. It's one thing to build models that can reason based on like all the kind of encyclopedic knowledge of the world, but really in order to solve really difficult challenges in the world, you need to experiment through trial and error in an environment, and it's much more cost effective to do that in a simulated environment than to do that in the real world. Like if let's say you want to improve self-driving car's ability to avoid a specific kind of failure cases, you can start from examples of an accident that the car has gotten into, but then kind of step back and then simulate different actions that the car could take, and then learn from that, get a reward signal from that, and improve. So it's a much more scalable and cost-effective and safe way of essentially improving those models to do that in simulation versus doing that in the physical world.
A lot of these companies are doing this, like Waymo and I know there's that Wabi, the self-driving car company. They have their whole simulated, they call it like Wabi World or something like that. It's like this world that they build. Is that are you doing essentially that for them, or are you taking a different approach?
Our perspective and like our general like approach is that we want to build models that are generally useful. Of course, as we do partnerships with different companies, there is specific work that needs to be done to kind of incorporate their data to make sure the model performs well in those cases. But as much as possible, we want to provide kind of a unified model that can work in a lot of those domains.
Do you think does it ultimately end up where you have, like, let's say a car company wants to operate in a city? Do you create a sort of like virtual 3-dimensional city and then sort of have the scenarios generated, the simulations generated within that world, like a video game? How do you see that?
The video generation models and kind of world models that we build are leveraging primarily 2D data. So they're built on top of essentially pixel data. So we think that's the most scalable kind of modality that we train kind of models on. And a lot of the 3D understanding actually comes from like even like models that are trained on just 2D data build a pretty robust 3D understanding of the world and enable that kind of consistency.
And does that 2D data have to like mimic actual cities and stuff like that, or is it just like, do you think it's like have a car do this maneuver at this intersection, and that sort of thing?
It kind of depends on a case-to-case basis. I think those models can generalize quite well, but they're able to perform well in unseen scenarios. But it really depends on if they're not performing well in a specific case, then you need to kind of bring data that's kind of on those specific scenarios or that specific environment to improve performance on those dimensions.
It's an interesting area. I mean, as you've sort of gotten into this robotics business side of the business, have you gotten a sense of like where we are with robotics in general at this point? And there's so much talk of humanoids and an explosion in robotics. Like, what do you see? Do you think we're at an inflection point in that space?
In my mind, and then from what I'm seeing, I think again there is definitely a lot of hardware bottlenecks, but I think a lot of the bottlenecks are on really building kind of great. Essentially are on the software side and figuring out how do you build models that can deal with the complexity of the real world, whether that's kind of on a manufacturer setting, on like a household setting. There is so much complexity in making sure you can kind of navigate, interact with like in a diversity of different environments. That's really difficult to solve with more kind of traditional techniques. And so this is where like our work has been kind of focusing on in like if like, and our hypothesis and kind of is that if you're able to build like good enough simulators that you're training those essentially kind of visual action models in, that's a much gives you a much better grade of improvement, and you can really make those you can make those models a lot more capable.
Do you have a prediction for like when we'll start to see these humanoid robots out in the world, or do you think we're farther away than some people like to?
A lot of people underestimate the progress that will come from exactly what I mentioned. I do think then I would not be surprised if in the next 5 years we're going to see kind of humanoid robots deployed in a wide variety of different settings.
What do you think about like just autonomy in general? Are we going to be at level 4, level 5, in the next few years, or will it take more time?
I think the difficulty is always predicting. Like it has been easier to make self-driving cars in particular cities, in particular environments. I think the challenge has been how do you make sure that you can deal with like all the different scenarios and all the different kinds of roads, all the different kind of weather conditions in a predictable, reliable way, and that takes longer than people think. So I don't want to make any. I don't want to commit to any dates there.
Back to just like your core here of film, or where you got started. I mean, when do you think we'll start to see like or will we even see a difference in what movies look like when we go to the screen? I mean, we're all sort of used to like, okay, we live in the CGI world, right? We're used to like the Marvel movies and all the crazy special effects they're able to do. And CGI totally changed the way film looks, right? When do you think we'll see that with AI, like the AI era of film?
So one way I like to think about this is with every new technology that changes art or like that evolves art, you have a stage that's more, I would say, imitative. Like you're trying to, like right now we're in this era where you really, I think we're proving that you can make films that are as realistic, you can tell stories that are as good as with traditional film techniques. And that's, akin to, the early years or early decades of photography. A lot of like the goals of like there was the pictorialist movement that basically the main goal there was let's prove that painting can be as like elevated of an art form as painting. But then you realize that there is new kinds of art, new kinds of things that you can create with this new technology that you just couldn't create with the old technology. And if we apply that to generative models, I think what's unique about generative models is this idea that you can essentially generate things on the fly based on what the viewer is wants to experience at any given moment. So this version of like interactive video is, I think, where a lot of those models will go towards. I expect there's going to be this like most, if we look like a few years from now, most content will be kind of generated on the fly, based on on who is actually viewing that content, and that can take a lot of different forms. It can be that it feels more like an immersive interactive theater experience where there is an existing story and you can view it from different perspectives, or it could be that you can make choices in the story and decide where the story goes. That interactivity can take a lot of different forms, but I think that's the thing I see the most potential in.
Like that almost sounds like video games too, right? I mean, where the world of film and video games start to kind of merge even more.
Yeah, and that also informs a lot of our kind of foray into gaming. We have this new kind of line of product called Game Worlds, where essentially their games are generated on the fly based on the premise that you can either provide as a user, or you can experience the games that are created by other users on the platform. So I expect there's going to be that kind of convergence between fully interactive experience like game and like more kind of offline sit-down experiences like film, and there's going to be all those things in the middle that are now kind of becoming possible with those models.
What's an example? Have you seen? Are there any the game world examples that you think are sort of, worth taking a deeper look at, or that have impressed you?
It has been impressive to see the diversity of different games that people have been creating. So there is more kind of traditional, let's say, escape room type of experiences where the goal is like it's a very specific goal you want to accomplish. There's people that have created more like trivia-like experiences of just learn about kind of different historical facts about the city, or experience a specific historical moment. There's people that have created games about being let's say a GPU engineer. Like they've seen someone creating a game about the kind of experience of being of the kind of the daily life of a graphics engineer. So the great thing is that it's so easy and so fast to like experiment with different kind of interactive experiences, that we're gonna see things that really like that new kinds of experience, new kinds of kind of stories that kind of have not been told before.
And we haven't seen like a AAA, like a big game studio sort of go in this direction yet. Do you think that's coming?
Definitely, yes. I think we've gotten a lot of interest from some of those companies to see how they can integrate generative models in both the way they think about kind of the asset creation process. So with those generative models, you can create new assets in the world much faster than some of the traditional techniques. But I think the more interesting parts are more using those models live as you're playing, in order to have the player make choices in the game and really shape how the gameplay is like.
Yeah, I wonder what that would cost. I mean, obviously the cost of this stuff is like coming down, but like just the token, if these games are hugely popular, right? If everybody is doing this like on the fly, I mean, there probably isn't enough compute power today to do something like that, right? I mean, or am I wrong about that?
Yeah, I think I guess it goes back to this idea that like if you think about what is the like one way to think about like what is the total inference demand that's going to be needed to that you're going to be using generative video models for. One perspective is you assume that like most films or most kind of media are going to be generated, and you take kind of the total kind of, let's say, the total duration of all films published in a year, and then you can convert that into into tokens. But I think it's actually going to be way more than that, because you're going to have those interactive experiences where essentially you're running inference on the fly and you're determining kind of the next, and you're generating that media experience on the fly. We're seeing obviously the amount of kind of the amount of compute that we're putting both on training and inference as an industry is growing quite dramatically. There is I don't think we're at the point where like that it can be like all of that can be served effectively right now, but things are like it's growing quite fast.
Have you tried to do that calculation, like just all the films in the world and what you think, plus all this new inference and everything? Like, have you?
So yeah, one way to do the calculation is all the seconds of film in the world. Another way is to take all the seconds of kind of for any display in like mobile phones, like desktop computer, the laptop computers, like any kind of display that exists, like take the amounts of frames that are generated per second and then convert them into tokens. I think it's even more because of the conversation about robotics and self-driving and like other domains where you're going to be generating essentially pixels that you're training models on in simulated environments. So it's difficult to put an upper bound to that calculation. I think it's difficult to predict.
So basically, like, there's no end in sight to this. It's not like you can get to a certain number of data centers or whatever and like, okay, we've got enough compute. I mean, it's basically just going to go on forever. I
think we're going to be bounded more by supply than by demand. Like there is
yeah. So you're probably like, long in NVIDIA stock, I guess, is that?
GPUs, yeah, I think there's going to be
right.
There's definitely use for more and more compute.
Yeah. Well, and so you're in New York, but are you spending a lot of time in Hollywood now, too, or do you feel like you need to?
We're spending a lot of time in LA. Yes, I think we built over the past few years relationships with film studios, and we work very closely with them. We announced some of that with Lionsgate, MC. Like there is obviously over the past year, especially, has been a lot of recognition that those technologies are here to stay, and like there is and on the other hand, those models have become a lot more capable in general, where it actually makes sense to move into production and not just to prototype with those models.
Do you spend time with like the the actual filmmakers, like on the creative side as well, talking to people? I'm just curious, like what that's like. Are they skeptical? Are they fearful?
Yeah, I mean, there is definitely a spectrum of reactions to the technology. I think there is more and more optimism that I see. Like people, I think it's a lot of the gap comes from what you hear about the technology versus actually using the technology yourself and realizing that it's just like the next evolution of creative tools. And it's really about translating your ideas into much faster into a final result, and it's not a tool that comes up with the ideas for you. I guess one of the more salient things that I hear from filmmakers is creatives have 100 ideas at a given point of like things that they want to create, and they have to be very selective about the things that they put actual resources and effort and into turning into reality. What those models now allow them to do is to really try out what that random idea that might be a bit too crazy to actually to actually invest a lot of effort in. They can try it in an afternoon and just see like what it looks like, and I think that ability to try out ideas much faster, I think, is the biggest value of those models.
Yeah, that is interesting. What's like the most surprising thing that you've learned from them that's like that sort of changed your view? I imagine because you were not a Hollywood person before you got into this, right? You were you were a technical person. What's been like eye-opening for you in getting sort of acquainted with that world?
Runway started from art school, so I had, even before Runway, kind of collaborated with filmmakers and have kind of had quite a bit of experience working in a wide range of different projects. I think perhaps the most surprising thing, which has been just the kind of the richness and kind of diversity of different workflows that people have around those models, and figuring out. I think it has been always difficult to figure out exactly like what the right controls to bring on those models. So like when we started with our earliest video generation models, you had very simple forms of control. You can just only provide a kind of text prompt turned into video, and then the thing that we shared immediately was, I want to have control over how the camera moves in a scene. I want to have control over how different kind of objects move, how different kind of how characters, like the expressions of characters and things like that. And then we build specialized tools for all those things. But I think even that wasn't enough. Like everyone, like every creator and every artist has their own process, and you really need to build tools that allow for this level of like intuitive control, and like making sure that you kind of can fit into everyone's process. I think has been the hardest thing to get right, and it's the thing that we spend kind of most of our effort, I would say, on as we think about the application of those models.
You want to just simplify it, right, and get away from this world where, like, some of these video editing suites are like so complex and there's so many different features, and you're moving in that direction, I guess. Like, as people they just want more ways to control it.
So I think the reason why things, the previous generation of tools has it gets more complex so quickly, is because essentially you want to please everyone. You want to make sure that like everyone's process and everyone's workflow is addressed within the tool. The beauty of the generative models is that they can adapt to your process and your tool, and you don't have to necessarily specialize those models for a specific workflow. So like if you have a specific way of, like, let's say doing blocking, or which is essentially like determining kind of the composition of a scene, and you have a specific way of like that you like to sketch and storyboard, models are able to understand your process and your way of sketching and prototyping, and that's a new paradigm compared to the kind of old school paradigm of tools where you had to build specialized interfaces for all those workflows, and so those models are both more intuitive, but also can be more specialized. But at the same time, you don't have to build specialized models to address every workflow.
Wow! So basically, everyone's got, it's like their own personalized, like software suite for editing and creating this stuff.
Yeah, I think that's the paradigm we're going towards, is this idea of you're generating the interface on the fly based on exactly like how you like to create.
That's crazy. I want like a little slider here that will let me just like pan the camera back and forth or something, and that could just like show up, and you're
exactly. Or you can sketch exactly how you want the camera to move, or you can there's so many permutations and combinations of inputs.
Right. That's a crazy, and you think about how that, once that becomes reality in like sort of all software out there, that's pretty powerful. I think we'd all love to have our own personalized software on our computer. And
I think that's also one of the things that people might underestimate currently. So we have the rise of vibe coding. You can create a new application on the fly based on kind of very simple commands. But I think that still assumes that that you have the same paradigm of like kind of someone develops an interface and someone uses the interface. I think we're gonna go to a point where you essentially have the interface kind of be created on the fly exactly for the task that you want to perform.
It's gonna be kind of wild to see what people do. with all this stuff. Well, I hope you enjoyed the conversation. You can read more in print over at semafor.com. Sign up for the Semafor Tech newsletter to get all of our content on technology. It's a free twice-a-week newsletter, and I hope to see you back here soon.